Hey y'all. Today we're going to be taking a look at chords and arcs. So we're going to continue our study of circles. We're going to talk about congruent central angles and congruent chords. We'll be using Pythagorean theorem to find diameter and distance of chords. And then we'll be taking a look at some angles and bisecting angles. So let's go ahead and jump into things. Chords and arc. A segment whose endpoints are on a circle is called a chord. So I have circle O here. So O is the center of my circle. Okay, so O is the center of my circle, and I have a chord. The chord goes from one end of the circle, so to speak, to the other end. So a segment whose endpoints are on the circle. So PQ is a chord. Also, if I had a diameter is also a chord because the endpoints are on the circle. So that's called a chord. Arc PQ would be the distance around here. So from P to Q, the measurement could be 27 degrees, 37 degrees, 57 degrees. So whatever it is an angle on the outside, and that part is your chord. So we represent that. The curvy part represents a chord, which is an angle, a degree on the outside. And PQ represents a chord that goes through the circle. If it goes through the center of the circle, it's a diameter. So that's a special kind of chord. So some things that we should know based off of chords. So these 3 things we should know. Within a circle or incongruent circles, 1, congruent central angles have congruent chords. 2, congruent chords have congruent arcs. 3, congruent arcs have congruent central angles. So I've already drawn in 2 circles here. I try to make them as congruent as possible. I have circle O and I have circle P. So I went in, I drew in some chords. We know BC is a chord, DF is a chord, and we're going to go through and label some things we know. So first off, I told you that these were congruent circles. So I have circle O. Circle O is congruent to circle P. So circle O is congruent to circle P. If I know that these are congruent, then there's lots of things that I can say. I can say that arc BC is congruent to arc DF. So arc BC is congruent to arc DF. So over here, if I point to arc BC is congruent to arc DF. So that's something that I can say since I know that these are congruent circles. Other things that I know that angle O is congruent to angle P. Angle O is congruent to angle P. So this is angle O, and then this is angle P. So I can say that BOC is congruent to DP. So those angles are congruent. And I also know that BC is congruent to DF. So BC is a chord and DF is a chord, and they are congruent to each other. So these are all lots and lots of things that I can say based off of the fact that I have congruent circles. So congruent central angles have congruent chords. My central angle, the center of the circle, the vertex is in the center of the circle. That's what makes it a central angle. So BOC is congruent to DPF. Number 2, congruent chords have congruent arcs. So that's what we were saying about BC and arc BC, DF and arc DF. And then number 3, congruent arcs have congruent central angles. So a central angle has the vertex in the center of the circle. Okay. Within a circle or incongruent circles. So within a circle or incongruent circles, 1, chords equal distance from the center are congruent, and 2, congruent chords are equal distant from the center. So notice these are just the vice versa of each other. So if you have chords equal distant from the center, then they are congruent. Vice versa, if you have congruent chords, then they're equal distant from the center. So these are just like A thus B and B thus A. So they're vice versa of each other. So we're going to go through and do some examples here to make that make sense for us. So I've drawn in some circles here. All right, there we go. Number 1, Find the value of B in the circle. So I have some chords. I have chord L, and before I even start explaining, I drew these circles and stuff in. So if the drawing isn't drawn to scale, it's okay. You just go off of the numbers and the things that we're given in the circles. So I have a circle here. I have chord PR and I have chord SR. I know that from P to Q, that's 12 and a half, and I see some tick marks here, so we're going to have to use that. I see that the distance from the center to this chord is 9, and the distance from the center to this chord is also 9. So based off of what we just had up there, it says chords equal distant from the center are congruent. So this chord is 9 spaces away from the center, and this chord is 9 spaces away from the center. So since they are equal distance from the center, they must be congruent. So if PQ is 12.5, then QR is also 12.5. So I know that because these tick marks means congruency. So if I add this together, PR is equal to 12.5 plus 12.5. So that gives me 25. So if PR is 25, then SR, which is B, which is what we're trying to find, the length of SR, chord SR, B must also be 25. So the answer to this is 25. So how do I know that? Let me zoom out a little bit and reread what was up here. It says chords equal distant from the center are congruent. SR and PR are both 9 spaces away from the center. So by definition, they are congruent to each other. Let's try number 2. Find the value of X. So let's look at our picture and see some things that we know. I see this chord here. So the length of this chord is 18 plus 18, and the length of this chord is 36. So again, we have to go by what's given to us in the picture, even though my circle is not very circle-ish. We have to go by what's given to us in the picture. So this chord is 18 plus 18. So the length of this chord is 36. So I have 2 congruent chords. So since I have 2 congruent chords, by definition, they must be the same distance away from the center of the circle. So if this space is 16, this space must be 16 also. So the length of X is 16. And we got that from number 2 up here. Congruent chords are equal distant from the center. Again, congruent chords, both of these chords were 36. They are equal distant from the center. So if this is 16, this is also 16. Now we're going to move into diameters and take a look at perpendicular bisectors and things like that. So you definitely may want to jot these down in your notes, and I'll go through and read them and explain them, and then we'll definitely jump into some examples. So the first one says, in a circle, a diameter that is perpendicular to a chord bisects the chord at its arc. So let's go through and make sure we know what some of these words are. Diameter is a special type of chord that goes through the center of the circle. Perpendicular means it's going to make 90 degrees. Bisect means it's going to cut it in half. And we've already discussed chords and arcs. The second star says, in a circle, a diameter that bisects a chord that is not a diameter is perpendicular to the chord. And the last one says, in a circle, the perpendicular bisector of a chord contains the center of the circle. So that's important. So the perpendicular bisector of a chord. So 90 degrees cuts the angle in half. So perpendicular bisector of a chord contains the center of the circle. So I have a picture here. Okay. So I have circle T. Circle T with diameter QR bisects SU at V. So circle T, the center of my circle is T. Diameter is QR. So it goes through the center of the circle. It's a special type of chord. It's the diameter. This bisects SU. So that means it's going to cut it in half. So bisecting means it's going to cut it in half. Keep reading, and it bisects at V. So it bisects at this point right here. Bisects at V. And we also know that QR is perpendicular to SU. QR is perpendicular to SU, meaning it's going to make 90-degree angle. So QR perpendicular. This is our symbol for perpendicular, SU. So it makes a 90-degree angle. Since it makes a 90-degree angle, as we go through and do some problems in just a minute, we are going to be using a lot of the Pythagorean theorem. A squared plus B squared equals C squared. So since we have perpendicular bisector and we're working with 90 degrees, we're going to be using quite a bit of the Pythagorean theorem. So let's go ahead and put this theorem into action. So here is our first picture. We want to find the length of R. So I have a chord LM, and the length of that chord is 14. I see a perpendicular here by that 90-degree angle that's given. I know that KN, the distance there is 3, and we're looking for KL. So we're looking for the length of R. We have a diameter, not diameter, but we do have the chord that is perpendicular here. So we're going to be doing the Pythagorean theorem. So things that I know, since these are perpendicular to each other, perpendicular to the chords, I know that that is a bisector. So LN is 7 and NM is 7. So let's label that. So it's a bisector. That means it's going to cut it in half. If from L to M, the whole distance is 14, that means this line cuts it in half. KN is my perpendicular bisector. This is 7 and this is 7. Now I have enough information to do the Pythagorean theorem. So I'm doing the Pythagorean theorem and find a different color here with this triangle that I'm trying to highlight in blue. So I'm doing the Pythagorean theorem with that triangle. So the Pythagorean theorem, I'm going to be doing 3 squared plus 7 squared equals R squared. So my legs are 3 and 7, and we're looking for the hypotenuse. That's what we're looking for. So here we go. So we add this together, 3 squared plus 7 squared. We type that in Desmos, and make sure you take the square root. So it's going to give you 58 once you do it. Take the square root of both sides, and I'm going to round a little bit, round to the nearest tenth. So there we have it. So Pythagorean theorem, a squared plus b squared equals c squared. Take home point here. You have a perpendicular bisector. It's going to cut your chord in half. So the whole length of my chord was 14, so that means that's 7, and then that's 7. All right, next, number 2. I have a different circle here, but I still can tell that I have a perpendicular bisector. So I know that if from A to C, if that space is 11, then from C to this point isn't labeled, but I know that this is 11 and that's 11. So I have a perpendicular bisector. BC is perpendicular to AC. So I'm going to put my 90 degrees in there. BC is perpendicular to AC. So now I have enough information to set up and do the Pythagorean theorem. This time I have the hypotenuse, I have a leg, and I'm looking for the other leg. So when I set up and go through and do the Pythagorean theorem, it should be y squared plus 11 squared equals 15 squared. So be careful. The first one that we did, we were looking for the hypotenuse, which turned out to be the radius. This one, we're given the hypotenuse is 15. That has to go in place of C, and then we have our 2 leg lengths of 11 and y. Go through, solve this. So we're going to get y squared, 11 times 11, subtract that out. This will give me 104, and take the square root of both sides. That's going to give me 10.2. So the length of y is approximately 10.2. And I know this because it says a diameter that bisects a chord that is, it says if I have a bisector that goes through something that's not the diameter, then it's perpendicular to the chord. So CB is definitely not a diameter, and this here is definitely not a diameter. So the perpendicular bisector of a chord contains the center of the chord, and it's a bisector. All right, a couple more. Number 3. So this one isn't any math involved. I just want to make sure we can understand a few things here. So if I have radius OX, so here's my picture, radius OX, that bisects angle AOB. So angle AOB is a central angle. AOB, central angle, the vertex is in the center of the circle. What can we conclude? So if radius OX bisects angle AOB, what can we conclude? We can conclude that angle AOX and angle BOX are congruent to each other. So we can conclude that angle AOX is congruent to angle BOX. So AOX is congruent to BOX. So AOX. Okay. So those two angles are congruent to each other because it says radius OX bisects AOB. Other things I conclude, I know that chord AX is congruent to chord BX. So AX is congruent to BX. AX is congruent to BX. Let's see what else we can conclude. We also know their arcs are congruent. So arc AX is congruent to arc BX. So the measurement outside of here, AX, is congruent to the measurement outside of here. There's probably some other things that we can label, but I just want to focus on the chords and arcs that we were getting into today. And last problem, we're going to go through and do one more on number 4. Find the length of the chord. So again, we're going to be back using the Pythagorean theorem, and we want to find the length of the chord. This one is different than the other ones. The other ones gave us the length of the chord, and we were looking for a leg or hypotenuse of the triangle. This one, we have a hypotenuse and a leg, and we're looking for the total length of the chord. We're still going to be using Pythagorean theorem. So right triangles, hopefully you think Pythagorean theorem, Pythagorean theorem. So here we go. We have a hypotenuse, which is 6.8. That's our hypotenuse, 6.8 squared. We have the length of one leg. Now, I want to find this length here first. So instead of using X, I'm going to use another letter, and I'm going to say Y. So I'm only going to find the space. Let me highlight here. I'm only going to find the space from here to here. So I'm going to find that space first, and then once I get that space, I'm going to multiply it by 2 so that I can find the length of the whole entire thing. So again, I'm going to find this distance here, and then I'm going to multiply it by 2 because I know that this line segment here is a perpendicular bisector, so it's going to cut it in half. So I go through and do this. This gives me the following. Again, feel free to use Desmos or any kind of calculating tool to help you there. Subtract 16 from both sides. And then I'm going to take the square root. And that gives me 5.49. Now, this only gives me the length of this section right in here. I want to know the length of the whole entire chord. So I just need to multiply it by 2. Once I multiply it by 2, and let me just know that this is X. Excuse me, this should be Y. I changed my variable there. That should be Y, and then this is Y. Okay, sorry about that. So this should be Y. You take the square root of both sides. That should be Y. So this distance here is 5.49. But I want to know the length of the whole thing. So I'm going to take this and multiply it by 2. So that gives me 10.99, etc., etc. So almost 11. So it is about 11. So what should you learn from today? You should know that within a circle are incongruent chords, congruent central angles, and congruent central angles, lots of C words, have congruent chords, and congruent chords have congruent angles. You also should know how to use the Pythagorean theorem to find the missing length for a chord, a radius, or a diameter. So things down here. Notice with all 3 of these problems, we did the Pythagorean theorem. A squared plus B squared equals C squared.